at taking a machine learning model into production. How do you monitor the model, and kind of talk about the different aspects of a responsible AI system. So, so responsible AI is something that is talked a lot in the industry. It was called, I mean, there are different terminologies. You could look at it. Some people call it ethical AI, but in general, the idea is that as you build machine learning models, you kind of look at the fairness metrics, the ethical considerations of it, and get into the more of how do you have a standardization across the board of how you deploy machine learning models. So I'll talk about some patterns. Again, these are not like set in stone. I mean, these things are evolving. So definitely you'll see new things coming in this direction. So my goal of this workshop will be just to give you, equip you with enough patterns where you can understand that this is what is happening. These are some of the best tools as of now for this particular application, and then you can as new technologies come in, new tools come in, you can kind of consider them for a particular problem. So we'll start with the first half session. We'll focus more on why we need responsible AI. It will be slightly less technical. It will be focused on what are some of the problems we face with AI systems. We'll talk about AI fairness and bias, and I'll just introduce some of the tenets that we see from the responsible AI perspective. And the second half will focus more on actual implementation, looking at metrics, monitoring, and explanations. I'll give some reference architectures, which are right now very popular in the industry. And again, as I said, these things keep evolving, so there's nothing set in stone. I have a couple of demonstrations, basically Jupyter notebooks that talk about how this is done. And depending on time, I can walk you through the code examples as we progress. A little bit about myself, and I mean this is already done. So I lead the AI research team at Persistent. Uh, Persistent is a global company. We have offices all across the world, headquartered in India in Pune. I am based out of Goa, which is we have a 500 people office here where I'm located, and we have offices in Europe, North America, about $500 million company. Primary focus of us is on banking and healthcare and getting into industrial and high tech. I'm also the author of the book Keras to Kubernetes. This talks about taking a machine learning model and deploying it into production. So yeah, that was something I developed. And before Persistent, I worked at GE at Research, Energy, and Transportation, like was mentioned. Okay, so let's get started. So first, what is the need for responsible AI, and how does this term come into place? Now, as you know, I mean, I'm most likely preaching to a choir here. Data is the new oil in today's system. The companies with the more data, those are the ones who are becoming successful. And AI is the new electricity. This is the term that Dr. Andrew Ng coined. So we need AI to process this large volumes of data and make sense out of it. But again, with great powers come great responsibility. So we see these headlines, like you may have read some of these. The algorithms are being used to grade essays, and then what if the algorithm is flawed? I mean, it's not. You wouldn't compare that to performance of a human teacher. Same thing now if you're applying for a loan or a healthcare insurance coverage. Now algorithms, machine learning algorithms are playing a role there. So what if these algorithms are biased? They take unnecessary or unintentional features and make a decision based on that. How do you tackle that? So, and how do you quantify that? How do you know that your algorithm that you're building is not actually doing that? I mean, that's the one aspect of responsible AI. The second aspect is talking about hidden technical depth and reproducibility. This is a nice paper. I'd highly encourage, and I have references at the end which has links to all this also. And I believe the slides will be made available either on GitHub or directly by Anna. So here we are talking. This is a nice Google research paper that talks about the actual ML code. When in the actual production, the actual ML code kind of is a pretty smaller piece of it. And there are established libraries, established algorithms. There are so many things you can try and evaluate what is best for your particular problem. The majority of effort kind of goes into finding the configuration, collecting the data, doing the feature extraction, process management, serving infrastructure, and monitoring the model. So if you're not paying attention to that, especially in the industry, you end up building a lot of technical depth. And then when you want to make the system improve the quality of the system, you end up spending a lot of time correcting these things and less time on the actual model. So now, if you see in the industry, a lot of machine learning platforms are being evolved, which tend to take care of these different concerns, so that data scientists can focus on the actual ML process, or the ML engineer can focus on the algorithm, and the rest of the things the platforms try to take take into account. A lot of platforms like H2O.ai, Data Robot kind of tends to handle this issue. The other problem is on reproducibility. So this is an interesting article from Nature magazine, where they conducted a survey of 1500 1500 researchers. Now this is just in general, and they found that there was a major reproducibility crisis, in the sense a lot of papers are published with a very high accuracy numbers, 90%, 99%, but then you can't really reproduce the code. Either the code is not shared, or it is not in the state where you can read. And we run through this a lot. I mean, we get excited about a new research, but it becomes difficult to actually reproduce if all the components are not provided. So it begs a lot of standardization, and this happens a lot in industry also. Like if you take a big organization, a lot of our customers, they have many data scientists who kind of prefer their own tools, own way of doing feature engineering. So it works when you are solving an isolated problem, but when you have to combine your efforts, you kind of run into a mismatch, and that causes a lot of effort to actually standardize things. Again, the technical depth problem. So this is something that is very relevant in the industry, and these two are the main reasons why a lot of people are talking about reproducibility. One is the ethical implications, the fairness part, and second is the reproducibility and technical depth. So a responsible AI system should ideally focus on both aspects. It give you enough ammunition to tackle both these problems, or at least quantify and make sure that you don't have this problem. So we will take them one step at a time. So we'll start with ethics of AI systems, and just some examples. These are just news articles that I picked up. Amazon, as you saw, I mean, some of the problems that we have seen in the industry. Amazon introduced a recruiting tool, and that was highly biased against women. And the reason was that this tool was trained on data that was historical, and historically they were different because of different regions. Women were less selected for certain jobs, or there were less women applicants. So that inherent bias kind of crept up in this tool, and the tool started becoming biased. Now, this was definitely not something Amazon wanted to do, but it just happened because the data was biased, so your algorithm got biased. And now there are tools, and I'll show an example of one of these tools, which can actually help you measure, quantify the bias in your algorithm. And there are tools by which you can even mitigate it, because and while training. Second example is the more recent one, Apple Card. I mean, this became very popular, especially in social media, when so Apple introduced this Apple Payments Card in I believe with Goldman Sachs, and they would assign some credit limit to different folks based on different factors, and it was found that under the same condition, a male and a female would get different credit lines. In fact, there was a 10x difference, and this was pointed out in a tweet by Steve Wozniak himself, that him and his wife, though having the same exact features, factors affecting their credit, they got two different credit lines. So this was a major issue, and I think this was discontinued. And this is an example of fairness through unawareness. It's a term in the industry where it's actually one of the definitions of fairness is you don't really consider, I mean, you don't consider a bias. You just collect data and do it, and you don't check if the data has a bias. So this was a classic case of that. It's not definitely not intentional, but this bias comes into the system. And the last, this is a classic example of in any AI fairness class, you will see this example. This was the Compass software, which was developed and used extensively by the US Justice Department. And it basically had a questionnaire, which was either filled by the inmate. So this was for the judicial system. So the inmates either filled it themselves, or somebody else would fill, a representative will fill it for the inmates. And it will ask questions like prior commitment, prior crimes, the locality where the inmate was living, and different personal questions. And based on that, it will create a score of recidivism, in the sense the score that will what is the probability that that particular person who has committed a crime will commit the crime again. And this was highly biased to a particular race, or against a particular race, I should say. And you could see from the snapshots that people of different races were given different ratings, though rest of the conditions were remaining same. So this was a major controversy, and this Compass software was discontinued. So this just wanted to highlight that this is a major issue that our AI systems have to deal with. And definitely, this is not an intentional issue, but it comes up in the AI systems. So one of the things we definitely need to consider is how do you measure fairness? Now, this is an interesting study because fairness itself, there are multiple definitions of fairness. And what happens is these definitions often contrast each other. So one of the older definitions is fairness through unawareness, that I'm not considering that attribute at all. So if I have a data set, I'm not considering gender or race at all. So in that case, whatever algorithm, whatever model I build will not be biased by that feature. Now this has been proven extensively as a false notion. Even though you eliminate that particular feature from your data set, what happens is these features are heavily correlated. So the bias does creep in. I mean, people have shown studies where, in fact, I may be able to, if I have time, I can show you a notebook with a similar example where even though you remove that particular feature, you can still see that once you put that feature back in, the results tend to get biased. So this is something that a lot of researchers have studied, and fairness to unawareness just doesn't work. Some of the other definitions are around demographic parity and so statistical parity and I think it's called uh, uh, yeah, so demographic parity, this tends to look at how what is the likelihood of a positive outcome. So it only looks at the selection rate, it doesn't look at the performance of a classifier. So this is something, and we'll talk about a couple of these metrics when I show the example. Counterfactual fairness is also something that is heavily studied, where you will the decision change if a particular protected attribute, and this in the legal terms these are called protected attributes like race, gender. If the protected attribute is changed, you change that particular feature from male to female, will the outcome change? And that's what counterfactual studies. And then couple of more mathematical definitions are equal opportunity and equalized odds, and you can read up there. So there are libraries which can help you look at your data and tell you if what sort of these fairness metrics exist, and how do they I mean, how does your data set work against these metrics. So this is actually an Excel, just an Excel sheet, which helps you calculate these metrics. Like oftentimes these metrics, you tend to think these metrics are very difficult, but it's not really the case. I mean, all you need is the tools to calculate this metric. So I can kind of in one of our blogs at Persistent, I kind of made this Excel sheet available. You can, I won't show it in this class, but you can read up on this. Basically, what you can do is you can consider two scenarios. In one case, group one is is male, and group two is females, and you can consider the predicted versus actual. So what it does is you just have to fill in the gray columns, where just take a hypothetical scenario. You don't even need to worry about the features, because the objective is to see how the metrics are calculated. So you just assume that you are solving for a particular case. You just find the predicted versus actual, and just populate these columns, and it will calculate your true positive, true negative, false positive, false negative. It will calculate your confusion metrics, and based on that, it will calculate some of your statistical performance metrics like precision, recall, etc. And then it will calculate these fairness metrics, because fairness metrics depend on the group. So you calculate the precision, recall in the males, and calculate in the female group, and then you compare. So based on that, these four metrics are calculated automatically for you: disparate impact ratio, statistical parity difference, equal opportunity difference, and equalized odd difference. And these are the formulas. So it's not rocket science. I mean, these are very straightforward. Just in this Excel sheet, you can calculate these. And you could use one of these tools, like IBM has this AI Fairness 360, and Google has this What If tool. You could look at these and try to calculate this fairness metrics. So since I have like 10 minutes, let me just pull this AI Fairness 360 up. If you're not seen this, I'll give you a 5 minute just an overview. It is a library which will help you. You can pass your data set to it. Of course, you have to do some feature engineering, make it numeric and others. But once you give the data set, it will tell you what are some of the metrics that are calculated. And what I really like is they have a very nice web demo. So this web demo lets you just on the fly calculate some of the statistical fairness matrices. So so what it does is first let you select a data set. Let's choose the Compass data set, the famous Compass data set, and the protected attributes are sex and race. And let's do next. Now what it is doing is on the fly for that particular Compass data set. Now, Compass is a famous data set. It's released in you'll get it on GitHub. It is calculating these particular matrices. So you can see the statistical parity difference is coming as minus 0.36, and which is coming as bias. The reason is, and you can it has a very nice explanation of it. The statistical parity difference typically should be between minus zero point 0.1 and zero point 0.1, and this is the definition of what the statistical parity difference is basically the favorable. I mean, this is the metric that is often used in legal terms, in legal cases also. How favorable is one group versus the other group, keeping all other factors same. So difference between the favorable outcomes received by the unprivileged group to the privileged group, that is what is calculated as a statistical parity difference. And this is the paper which introduced this term. So this I really like this tool. It right here, it gives you the definition, it gives you a calculation, and it gives you the paper that brings this up. Same way, there's equal opportunity difference, average odds, and disparate impact. And this is more based on entropy fields index. And you can look at one of these matrices, and using the library, you can apply it to your data set. Now, the next thing is once you select, say, okay, you know that this data set is biased. There is a bias on sex. Then you could do is you could apply one of the debiasing techniques. So this is something that is gaining popularity now. Now you don't know that your data set is biased. You tried this out from the metric. You know, okay, your data set has bias. Now, how do you mitigate the bias? Now you can go sample new data set, but many times in the real world, the data will have a bias. So there are some debiasing techniques which you can apply, which is more like they're adding some noise to your data set, and they help you reduce the bias. So the result that you get may not be 100% reflecting the reality, but it tries to do a trade-off that, okay, we add some noise, but because of that we are removing the bias, and we get a little less accurate data set, but it's most in many cases is acceptable for training a machine learning model. So this can be done at three levels. One is you can do it at a reweighing stage where you apply different weightages to the data. So and this kind of talks, and then there's a very good paper that comes with IBM 360 that talks about details of each of these techniques. So it's pretty good site for you to try out. So you can do it at the data level where you can reweigh the inputs, or you could do it at the classifier level, which is more of an adversarial debiasing, where you actually train another classifier to adjust the accuracy based on your calculations. And then the final one is you can do it at the prediction level. So here actually you're tweaking the predictions, because if it is a borderline prediction, then you are actually making it to an underprivileged class because you want to mitigate the bias. So these are the three techniques you can do, and in this tool you can just select one of the techniques and just say next, and it will actually apply this technique, and it will actually apply this technique and give you the new value of say statistical parity difference. So it was 0.36 before. Now it has made it into minus 0.03, which is acceptable as far as the rule of thumb case, where zero point 0.1 to minus zero point 0.1 is acceptable. So now it actually did a debiasing and gave you the result back. So this is a pretty handy tool. It explains to you how the data set has a bias, how you measure it, and then how do you apply some sort of a debiasing technique to actually reduce the bias. So now when you use it to train your model, you have a more confidence that this particular data set doesn't have a bias, and that will not be passed over to your ML model. So that's kind of in a high level overview. Let's come back to the to the slides. So